Welcome to Dr. B.R. B.Sc. Today we are discussing about BSc Statistics 3rd semester, applications of negative binomial distribution. See here in the applications of negative binomial distributions, theoretical part and problematic part is there. In the negative binomial distribution, what is the objective? See here, to know the situation where is the negative binomial distribution. The negative binomial distribution means that is minus, plus and minus. The negative binomial distribution is an appropriate. Find the parameters p. We are taking the parameters p of the distribution from the negative binomial distribution, the given description. See here, negative binomial distribution is used an entomologist to represent deaths of bacterial insects. In zoology we are taking number of bacterial bites inverse binomial sampling. See here, entomologists are using this is the binomial distribution, the bacterial insects. Moreover, is applied in the study of population models where we obtain constant rates of births and death and a constant rate of migration can be modeled with a negative binomial distribution. See here, study of population models. What we are taking here in obtain constant the rates of the births. Rate of the births of the constants we are taking here. What is the death rates and constant rate of migration we can find in negative binomial distribution. And also it is used to analyze the count data. How analyze the data? Environmental science is also one is frequently interested here in summarizing changes of abundance of particular organisms in the environmental for protection or impact assessment, that is particular matter or industrialization. Suppose we can take one example, estimation of the abundance of threatened species. The impact in species means we are taking in the zoology, also taking here at the habitat changes on the other numbers, that is ecological conservation. What is ecological conservation? So that sparrows, cell tower, radiations, and also Bengal tigers and deforestation also we are taking in this one. So what is the application of negative binomial distribution? Why we are taking the negative binomial distribution? In the modeling, the number of defaults on a loan before a certain number of payments. So we are taking the loan and we are taking the payments are made. Modeling the number of defects. So a Pratigamanalo, what is the number of defects in a manufactured products? Defects will be shown in manufactured and also defects in see here in the product before a certain number of units are produced here. Why? What is the real life application of negative binomial? How it can be used in the real life? For example, we could use the negative binomial distribution to model the number of days. We can take that the number small n we are taking here, see here, small n we are taking here, that is a random. A certain machine works specified by R, but before it breaks down. And this is, we can use in the polya, we can take that, see here, use polya for the real valued case. Why? Because R comma P we are taking here. So in R comma P we are taking here, we can take this is polya is a real valued case. That is when the failures are increasingly rare. And what is a negative binomial model used for? Why using negative binomial here? Why using negative binomial? That means the count is lesser than the variance of the count. అంటే విస్తృతి కంటే తక్కువగా ఉండాలి. The negative binomial regression రుణ ద్విపాద ప్రతిగమన ఏదైతే ఉందో, it is used to test for connection in between confounding and predictor variables on a outcome variables we are taking here. Negative binomial regression is most commonly used model over dispersed count outcome variable. See here, negative binomial regression is the most common using the model over, and also outcome variables also we can using here this NBD, that is negative binomial distribution. What is the real world application of the binomial distribution? Here are a few real life scenarios where a binomial distribution is applied. Suppose we know that real life distribution we can apply here. We know that they calculate the TRPs. We know that TV channels are calculating the TRPs. Any TV channel we are taking the TRPs here. Also calculating the TRP of a television channel by taking the survey of households whether they are watches some news channel or any serials they are liked or not, yes of the channel or not, no. In the manufacturing of a commodity, estimating between the used or unused materials, that is called BRAOU. What is an example of negative binomial distribution? We can take the problem here. A fair coin means a coin has been flipped here. Flipped means we are taking here until 4 heads come up 4 times. What is the probability that coin will be flipped exactly 6 times? We did not know it is flipped, 4 heads may become here. But this is a typical example of a negative binomial distribution since the problem asks about the number of trials needed in order to obtain a certain amount of success. Why? Because it is a success here. The distribution of the problems, the number of needed here, the 4 until head 4 times where it's a possible or not possible, we can checking here, but to obtain a certain amount of success. What is an example of a binomial distribution in everyday life? See here, what is an example of a binomial distribution in everyday life? For example, if we toss a coin, so we can toss a coin here, there we should be only 2 possible outcomes, that is head and tail. Only 2 possible, that is success and failure. But heads or tails and test is taken, then there could be only 2 results, pass or fail. See here, pass or fail, success or failure, or that is head and tail. This distribution is also called a binomial probability distribution. The 2 parameters n and p, here a binomial distribution. Why is a negative binomial used for Gini expression? What is Gini? జన్యుకు సంబంధితమైనటువంటి expressions. Essentially, the negative binomial is a good approximation for data whether mean is less than variance. సగటు less than variance, సగటు ఎక్కువగా ఉంటుంది. As this case, that is RNA. అంటే మనం DNA లాగా RNA టెస్ట్ కూడా చేస్తాం, that is a sequence count data. We use the Poisson. This will underestimate variability leading to an increase false positive DEJ. Poisson తో కూడా చేయొచ్చు, కానీ the underestimate of this variability increasing the false positive DEJ, and that's why we are using negative binomial distribution in Gini expression. See here, this is a Poisson, that is a NB nation, that is a negative binomial dispersion. See here, this is a p is equal to 0. See here, the frequency 0, 200, 400, but it is a Poisson distribution. You have to take in your dispersion, it is only 100 here. But negative binomial dispersion 0.01, here taking the 0 only. This is only graph you are taking, that is only 100 to 50 to 100, that the remaining part here. But negative binomial dispersion in 0.01 I am taking here. That is 0 to 100, this should be increasing here. See this graph. Suppose some of the increasing the graph 100 and plus. But suppose I am taking 0.1. Again, the earlier graph we are taking 0.01. But this is a 0.1 taking here. See here, it is come to very exact graphing here. The geno, how it should be increasing here in this graph, 0 to up to 200. It is slightly narrow, slightly is increasing 0 to 200. It is taking here in the genu. So see here 0, how it is a graph, 0.01 how it is taking the graph, 0.1 how it is taking the graph for only negative binomial distribution. Why do we use negative binomial instead of Poisson? Why in a Poisson distribution badalu, why we can use binomial distribution? Poisson regression of over dispersed data leads to deflated standard error and inflated test statistics. Over dispersion may also result when the success outcome are not rare. success outcome is not rare in the Poisson, but negative binomial distribution is purely success outcome rate here. But in Poisson distribution also we did not, some of the equations is not rare. To handle such situation, negative binomial regression is commonly recommended. See here, this is a PMF probability mass function, see here. So that is a density, see here, there is a green color and also the red color, and other one, see here how it is increasing in the first and the density and the first probability mass function and second probability mass function, how it is differing, all the values. This is only in the second one, see here, this is only one color and this is a red color and this is a green color. This is a multicolor showing in a probability mass function, that is 0, 0.5, 0.10, 0.15, 0.20, 0.25. So see here, this is a Poisson and the negative binomial distribution. How it is a probability mass function? See here, this is a multicolored, this is a Poisson, this is a only single color, this is a negative binomial distribution. How it is a successive rate we are saying in the graph. What is another name of for negative binomial distribution? See here, it is known as Pascal distribution also. When we are taking the small s, however, it's continuous number. What is the continuous number? 0, 1, 2, 3, 4. There is a continuous number until infinity. The negative binomial probability density function, that is PDF, we are taking often called as Poisson distribution. No, we already told that is a Poisson. We can call that one Poisson distribution. How do you interpret a negative binomial results? We can interpret the negative binomial regression. Regression means pratigamana. దాని ప్రతిచిత్రము అంటే ద షేడ్, దాని వెనకాల ఉన్న మన యొక్క నీడ. సో ఇంటర్ప్రెట్ ద నెగటివ్ బైనామినల్ రిగ్రెషన్ కోఎఫిషియంట్ యాజ్ ఫాలోస్. ఫర్ ఎ యూనిట్ చేంజ్ ఇన్ ద ప్రిడిక్టర్ వేరియబుల్, ద లాగ్ ఆఫ్ ఎక్స్పెక్టెడ్ కౌంట్స్ ఆఫ్ ద రెస్పాన్స్ వేరియబుల్ చేంజెస్ by the respective regression the regression coefficient is, coefficient means దాని యొక్క ప్రతివిలువ ఏదైతే ఉందో, the predictor variables in the model are held constant, అక్కడ స్థిరంగా ఉండిపోవడం జరుగుతుంది. That is, we are interpreting the negative binomial result. See here, what is the example problem on negative binomial distribution? Suppose, take a standoff deck of cards. So we can take the 52 deck of cards we are taking here. We are scrubbing and shuffling and we are taking that one, the shuffle of them. Choose one card. So replace one card and repeat. One card we are taking and replace and shuffling the same here until you draw 2 aces. Why the number of draws is true? So why is the number of draws needed to draw 2 aces? 2 రావాలి మనకి అక్కడ, as the number of trial is not fixed. So therefore that is, you stop when the draw the second days. So second days వచ్చే వరకు మనం we can take it, this makes it a negative binomial distribution. అది ఎప్పుడైనా రావచ్చు, 52 కార్డ్ రావచ్చు, 42 రావచ్చు, ఎప్పుడైనా రావచ్చు. Until that we have to do stop when you draw the second days. This is called the negative binomial distribution. What is the negative binomial used? So when the mean of the count is lesser than the variance, mean of the count lesser than the variance అంటే ఏంటి, విస్తృత అనేది మీన్ కంటే తక్కువగా ఉంటుంది, సగటు కంటే తక్కువగా ఉంటుంది. Why? The negative binomial regression is used to test for connections between confounding and predictor variables on a outcome variable. Negative binomial distribution is most commonly used to model over dispersed count outcome variable. See here, very most important here, this is most commonly used to disperse the outcome variables we are using here. What is an example of a negative binomial worked? Negative binomial example ke negative binomial, why we are using here? If we flip a coin, see here, a fixed number of times and count the number of times can coin turns out a binomial distribution, continuing flipping the coin until it has turned a particular number of heads. Say the third head on flipping on times, third head వచ్చేదాకా flipping on 5 times, then this is a case of the negative binomial distribution. Why? Because we did not know that 5 times 3 సార్లు రావచ్చు, 4 సార్లు రావచ్చు, 0 times రావచ్చు. So then this is a case that the negative binomial distribution. Say negative binomial distribution formula. f of x is equal to n plus r minus 1 combination of r minus 1. So we have know that NCR. What is NCR? Suppose we can give the problem 10C5. 10 is the number, 5 is the combination. So 10 factorial by 10 factorial by 10 minus 5 factorial into 5 factorial. What is the formula? N factorial by n minus r factorial into r factorial. The condition is same. This is n plus r minus 1 into c, combination of c r minus 1 p power r cube power n. Can negative binomial is 0? Yes, 100%. The Poisson and negative binomial distribution both includes are 0. I already shown the graph earlier that is zeros here. When data structurally excludes zero counts, the underlying probability distribution must preclude this outcome to properly model the data. What is the symbol for negative binomial distribution? Already I told the symbols, that is r comma p. So we are using the negative binomial distribution implemented the whole form language, the negative binomial distribution, that is NBD. We are writing r comma p is the symbol of negative binomial analysis. What is the probability mass function we are taking here? What is the PMF? What is the probability mass function? We know that x is equal to k. And the first k minus 1 trials r minus 1 must be success. Why success here? And trial k must be success. See here, the first part is a lot of like a binomial. It's the part p of y r minus 1, that is y equivalents to binomial distribution, that k minus 1 and p. The first part gives k minus 1 r minus 1. So see here, see here all of you, k minus 1 r minus 1, that is we can write k minus 1 c combination of r minus 1. Already I told formula n plus r minus 1 c of r, n minus 1. The condition we are taking that much here, 1 minus p whole power k minus 1 minus of r minus 1 into p minus r minus 1. So see here of the earlier formula, I am going here, see again one the mathematics formula, see here p power r cube power n. See here p power r cube power 1. So p power r, so p place in place of I am taking 1 minus p k power minus 1 minus of r minus 1 in place of, so that is q place 1 minus q is equal to 1 minus p, that is p into r minus 1. The simplification of this one k minus 1 c into r minus 1, that is 1 minus p into whole power k minus r into p into r minus 1. The second part also the same, the multiply by with p. The negative binomial distribution of PMF. What is the PMF? We know x is equal to k. K minus 1 trials, r minus 1 must be success. Why? Why means we are multiple trials, one should be success, that means r minus 1 minus must be success here. And trial k must be a success here. The part is a lot like of binomial. In this p of y r minus 1, where y equivalents to binomial, that is we are writing k minus 1 comma p. First part gives k minus 1 c r minus 1, that is 1 minus p whole power k minus 1 minus of r minus 1. P in power r minus 1 we are taking of the earlier, the same here, k minus 1 of c r minus 1 with the combination 1 minus p whole power k minus r into p r minus 1. P kilo we are writing 1 minus p into p. The second part multiplication of by p. So p of xk, so k minus 1 c of r minus 1, 1 minus p whole power k minus r into p power r. For k belongs to, we are taking z or less than or equal to k. Negative binomial analysis. Why we know that the PMF? Now we can expectation we are taking here. What about the expectation? To see R is a success. The flip until we success 1, until success 2, until success 3, until success 4. But where? Until success R also we are taking here. The total number of flips is the sum of geometric, that is random variables. Let Z1, Z2, Z3, Z4 until Z are independent copies of GO of P. So this is Zi are called independent identically distributed IID. That the IID called is independent and identically distributed. because they are independent and identically probability mass functions. So E of x, this is a mean. E of x is the mean, so we are writing here E of z1, E of z1 plus z2 plus z3 plus so on z plus r. So taken that the mean we are taking the variance, we are taking the simplification, E of z1 plus E of z1 plus E of z2 plus E of z3 and so on E of zr. So mean is equal to variance we are taking, that is r into 1 by p. One, we have to take the problem here. A pediatrician which wishes to recruit 5 couples, each whom is expecting their first child, to participate in a new natural child birth regimen. Natural ga చేయాలనుకుంటే అడుగుతున్న డాక్టర్, P is a randomly selected couple agrees to participate. Second condition, that is see here, that is 5. Second one, P is equal to 0.2. What is the probability that 15 couples must be asked, therefore 5 are found to be agreed to participate, which S is equal to agrees to participate. What is the probability 10 of F's occur before the 5th S? See here, substitute on R is equal to 5. What 5 what get recruit? I am taking 5. That P is equal to 0.2. X is equal to 10. Indulo 15 undi, couple indulo 5 undi. So we are taking 15 minus 5, 10. So formula NB X R comma P. See here, that is NB 10 5 comma 2. So తీసేస్తున్నాను నేను ఎర్లియర్లో తీసేస్తున్నాను. సో 14 అవుతుంది, 1 తీసేస్తే, సో therefore 14 of 4 0.2 whole power 5, that is 10లోకి వెళ్ళి తీసేస్తున్నాను నేను ఇక్కడ తీసేస్తే, that is P is equal to 0.2, that is 0.8 here whole power 10 ఉంటుంది. 1లోకి వెళ్ళి 0.2 తీసేస్తే 0.8, 14C power 4. How we are getting 14C power 4? 14 factorial by 14 minus 4 factorial into 4 factorial. 14 factorial means 14 into 13 into 12 into 11 into 10 into up to 1. By division of 14 minus 4 factorial, 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Again 4 into 3 into 2 into 1. That into 0.2 whole power 5 and 0.8 whole power 10. All these multiplies here in the 10F's observed. So Px less than or equal to 10. Therefore, summation of x is equal to 2 to 10. So NB x is equal to 5 comma 0.2. The simplification of this one is, see the here 0.2 whole power 5. I am taking here 0.2 whole power 5, summation of x is equal to 0 to 10. X plus 4, see the earlier one, this is a 4 I am taking here. X plus 4 of 4, that is 0.8 whole power x. After this simplification, I am substituting x is equal to values here 0.164. Another example I am taking, if a boy is throwing stones, a boy throwing the stones is largest target, what is the probability that 10th throw is the 5th hit, 10th throw of 5th hit, the probability of hitting the target any trials is 1 by 2. What is a 1 by 2? Head is, it is a padochu, takochu, takakapochu, it is only 1 by 2. The boy should be, his target is 4 times in the previous 9 throws. Target is 4 times, but 9 throws, his 10th throw should be, is the target. So 10 minus 1, 9. So see here, 9, 9 see 4. See here, 5th 4 times and got 4 plus 5th target, 5th hit annadu kabatti. So 9 see 4, that is 1 by 2 trial kabatti ikkada what I am taking here 1 by 2 head and tail. So anni 1 by 2 le untai, head success aina 1 by 2 failure aina 1 by 2 kabatti 1 by 2 total 10 kabatti failure 4 తీసుకొని 5 సక్సెస్ తీసుకున్నా, లేకపోతే ఫెయిల్యూర్ 4 తీసుకొని సక్సెస్ 5 తీసుకున్నా, న్యూట్రల్ 1 by 2 తీసుకున్నా, టోటల్ 10 రావాలి. సో 9C4, the bases are same 1 by 2, 1 by 2, 1 by 2, 4 plus 5 plus 1, that is 10. So 9 factorial by 9C4 we are taking here. So 9 factorial 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 by 9 minus 4. That is 5 into 4 into 3 into 2 into 1, 4 into 3 into 2, 1. Cancel just some values, you are cancelling the values in the numerator and the denominator. The bases are same, so therefore 4 plus 5 plus 1, this is 1. So 10 here, so that is the total value 0.1230. A lot is known to contain 3% defective units. What is the probability that a quality inspector has to wait till 15th trial before defecting the third defective unit? See here, 3 defective units is there, but the probability quality inspector told that the 15th trial before defecting the third defective, అందులో 15th దాకా పోతే third defective until he selects the units one at a time randomly. Randomగా select చేస్తే అట్లా టోటల్గా 15 ఉన్నాయి. We are taking here 14 trials and there should be 2 defective, 3 defective నుంచి 2 defectives తీసుకుంటున్నాం 15లో నుంచి units, and the 15th unit should be a defective unit. And we can hypothetically, so here a chance that an item is defective. 3% అంటే 0.03. Formula 1 plus q is equal to p or q is equal to 1 minus q. అంటే 1 minus 0.3 తీసేస్తే 0.87. Required probability is 14 C2. See here, this is 14 trials and 2 defective. 14 C2 into 0.03 whole square, 0.87 whole power 12, 0.03. 14 C2 0.03 whole power, ఇది 2, ఇది ఒకటి బేసిస్ కలుపుతున్నాం. సో దట్ ఈజ్ సింప్లిఫికేషన్ 0. అంటే 14 C2 అంటే ఆల్రెడీ టోల్డ్ యూ 14 ఫ్యాక్టోరియల్ బై 14 minus 2 ఫ్యాక్టోరియల్ into 2 ఫ్యాక్టోరియల్. సో నెగటివ్ బైనామినల్ అనాలిసిస్ వేరియన్స్ హౌ వీఆర్ టేకింగ్ Z1, Z2 ఇంతకుముందు మేము తీసుకున్నాం. Z1, Z2, Z3 and so on, ZR be independent copies of GOP. So negative binomial, that is x is equal to Z1 plus Z2 plus Z3 and ZR. Variance is equal to variance by this is Z1 plus Z2 plus Z3 plus and so plus ZR. Until now we just reached x is equal to Z1 plus Z2 plus Z3 plus so on plus ZR. Variance అంటే సింప్లిఫై చేస్తున్నాము. Variance Z1 plus variance Z2 plus and so on variance plus ZR because ZI are independent. So independent అయినప్పుడు that is R into 1 by P, 1 minus P by P square. What is negative binomial? So negative binomial is the parameters are R, the number of successes needed P, the probability of success is a single trial, the number of trials need to get Rth success. Know that formula P of x k, that is k minus 1 CR minus 1. In P, in place of P, 1 minus P whole power k minus R. In place of Q, P power R. F of x k is ugly. Do not bother with it. So V of x is equal to R by P. Variance x is equal to R into 1 minus P by x square. One problem. An item is produced in large numbers. The machine is to produce 5%, machine లో 5% defective items is there. A quality control inspector is examining the items by taking them at random. What is the probability that at least 4 items to be examined? Under 4 items check చేయాలి to get 2 defective units. See here, suppose x is the number of good items estimated before the second defective item was found. The total number of items examined by the inspector is x plus 2. See here, 2 defective items is there. The previous is 1 item తీసేస్తున్నాం, that is x plus 2 minus 1. So that is x plus 1, 2 minus 1 is x plus 1. That items there is the 1 defective and the last attempt defected the second defective unit. So that is 5%, 0.05, 1 minus 0.05, that is 0.95. That is y greater than or equal to 4 items తీసుకుంటున్నాం కాబట్టి 2 items తీసుకుంటున్నాము, y is equal to 0 to summation of infinity, that is x minus 1 C1. So 0.05 whole square P square కాబట్టి 0.95 x power minus 2 సక్సెస్లో 0.95 తీసుకుంటున్నాం కాబట్టి this is whole total simplification is 0.0073, that is 1 minus 0.9927. Another problem, a certain types of missile has failure, probability 0.02. Denote that launch number of fourth failure. Find the probability mass function of n. Find the mean and the variance of n. Let x denote the number of successful launches the missile before the fourth failure అంటే x plus 4, x is equal to 0, 1, 2, 3. Given the probability missile is equal, given the one 0.02, that is we can take that p dash, we can say the probability of the missile launched here, ఇంతకుముందు తెలుసు మనకు p plus q is equal to 1, కానీ సక్సెస్ఫుల్లీ అన్నప్పుడు q dash is equal to 1 minus p dash, so 1 minus 0.2 is equal to 0.98. Now we are taking n minus 1, that is x plus 4 minus 1, ఎందుకంటే 3 successful failures, that is nth launch is failure. N minus 1 C3 P dash whole power 3 Q dash n minus 1 minus 3. The simplification of this one, n minus 1 C3 P dash whole power 4 Q dash whole power n minus 4 with n is equal to 4 comma 5 comma 6. The mean is equal to R into Q dash by P dash. R is equal to 4. The values are substituting here. Q dash is equal to 0.98, P dash is equal to 0.02. The mean 196. The simplification is equal to variance is equal to the substituting the values 9800. Another problem, E of x is equal to 10, root x is equal to 3. Can X has a negative binomial distribution? It is 0. Why? Because since is a negative binomial distribution, variance mean, so root x is equal to 9, that is not equal to 10, there is a mean. So this is the problems of this one. You can roll a dice until the 4 6s, not necessarily consequent you what is the mean and the standard deviation of the number of trials. So this one we are taking here. This is also the same finding here, RP by Q and RQ by P and standard deviation of the earlier one and success and failures. So in the negative binomial distribution can be used in situations where variance is larger than mean. It has wide applications in the field of entomology. It is also Pascal's distributions or binomial weighting times the distribution of the parameter or is integer. I already told it Pollard distribution is a real number. It is using the environmental science and zoology, and also in the Pascal distribution we can find it is a very useful, better than the Poisson distribution, negative binomial distribution using in your real life. This is used in your BSc third semester statistics, useful to you. Thank you one and all.